last day of this amazing Grid Science meeting. So today we are going to do a first session on reporting the discussion of the and plenary activities we've been discussing all this week. The first one in reporting is Joanna, reporting on science session 1, microwave, sea and sea surface temperature, algorithm development and operational and research applications. Thank you, Joanna.
Good morning. Thanks for being here. Not necessarily awake, but still. So this is the session 1 reporting. It's a summary of the presentations and a summary of the GHRSST priorities and discussions that took place. I'll just refresh a bit your memory about what was discussed. We won't dwell a lot on this. So the purpose of the session was to evaluate microwave SST retrievals, system strengths, limitations, and set the priorities for future GHRSST compliant passive microwave SST products. Of course, the focus was on following state-of-the-art existing and future sensors, the AMSAR2, AMSAR3 transition, MICAP, and the upcoming SIMR. And there were discussions and presentations on technical issues such as radio frequency interference, land sea ice contamination, scan biases, etc. There was also the request of a promoted international cooperation among agencies and developers to ensure SST data record consistency and usability. So the highlights from the session 1 presentations, we had one presentation regarding the microwave imager combined active and passive, which is on board the Chinese Ocean Salinity Mission. There was a presentation on the performance. The C-band was reported better than 0.5 Kelvin. The footprint of the C-band is around 15 by 25 kilometers. The L-band footprint is around 50 by 75. The high-resolution SST product is still not official operational product, but it will be provided at 15-kilometer resolution. The SST retrieval uses a Bayesian optimal estimation. There has been a validation against IQAM and CMC SSTs that show biases in the order of 2 decimals and RMSE around 0.76 degrees. Some key issues have been identified with respect to the C-band RFI, land contamination near the coast, significant high latitude data gaps, and the future work will include deep learning and improvements in coastal areas. Then we had the presentation of the CDR of SST from the AMSAR series, and it's a plan from JAXA to release a sea surface temperature climate data record, providing observations since 2002. Currently, there's work on the AMSAR2 data. Some main limitations of the AMSAR SST products were identified with respect to stripe artifacts, over-smoothing, and there have been some proposed activities on how to mitigate those and create a high-quality CDR from the AMSAR series SSTs. The main features of this CDR are the provision of subskin SST and the sea surface wind speed. And the key features will be the optimal noise filtering, microwave infrared cross-calibration, and coefficient-based physical retrieval, along with assessment of the spatial resolution. It will be GHRSST compliant, GDS compliant, and will include wind, cloud, rain, and land contamination. Then we had the presentation on the status of AMSAR3, that, of course, guarantees continued observations of over a passive microwave. The AMSAR3 was launched in June 2025, and it's currently in initial calibration and validation phase, with early data releases available. The swath width is a bit more than 1,500 kilometers. The antenna size around 2 meters. Revisit time around 3 days. It includes channels for solid precipitation retrieval and water vapor analysis for NWP. There has been some intercomparison with IQAM buoys that shows RMSEs in the order of 0.5 degrees for the multiband retrievals. There were some scan biases identified and corrected, and some calibration errors within 20% of the field of view for all channels. The AMSAR2 and AMSAR3 have different orbit and sampling that should be taken into account when creating the CDR. And of course, there was a highlight on switching off the AMSAR2 near real-time dissemination when the AMSAR3 is going to go live. And if the presenters have any comments on these slides, you are welcome to get back to us. We didn't have time to do that before. But if you see something you don't think we got the message from, just raise your hand and we can correct it for the report and for the presentation. And then there was a presentation on SIMR on the overview of the level 2 global ocean and atmosphere product. SIMR is expected to launch in 2029. There was a presentation on which of the geophysical products will be retrieved for ocean, which will be SST, salinity and winds for the global. SST will be provided at a resolution less than 15 kilometers in GRIST format. The retrieval is based on the cascade optimal estimation, and there are ongoing simulation experiments in test areas that are such as the Agulhas current, the Bering Sea, various places that yield mean errors and standard deviations around 0.2 degrees Kelvin. And the scientific ATPDs for processing and resampling are currently under development. The validation plans to rely on the existing EUMETSAT tools, and the presenter has requested for GRIST feedback regarding the output content and format, the access method, the grid, etc. And then finally, we had another presentation for SIMR, which was on the SST, IST retrievals from AMSAR3 and SIMR, of course. The plans for operational passive microwave SST and IST products from AMSAR3 and SIMR were presented with key applications related to surface energy budget, synergy with infrared to improve coverage under clouds, and create CI surface temperature CDRs. The SST retrieval relies on a two-step statistical algorithm trained using the ESA CCI SST matchup database. The near future plans include tuning of the SST algorithm on the AMSAR3 data. And then on the SIMR SST and IST product development, that's happening within the framework of the ISIL2 PAD project. The algorithms are open source, ATPDs available online. Sample SIMR SSTs are currently being generated, and the C-band is also used for IST monitoring with a target resolution of around 15 kilometers and total standard uncertainty of 3 degrees for freezing conditions. And then there's an uncertainty determination based on the Monte Carlo approach. And from these presentations, we had some time for questions and then discussion on the GRIST priorities and recommendations. And here I just sum up the 4 bullet points, or Daniela summed up the 4 bullet points, actually. I don't know if there's any further time for discussion now, but first of all, we have decided to support a formal GRIST statement encouraging the maximum overlap between the AMSAR2 and the AMSAR3 to ensure cross comparisons, and then promote the coordinated evaluation and intercomparison of emerging passive microwave SST products. The intercomparison task team currently has one active task on the infrared passive microwave merging for level 4 reconstruction, which could contribute to the AMSAR2, AMSAR3 comparison, but obviously more in-depth comparisons are needed, and for that the potential creation of a passive microwave task team has come up, and it would be nice if the GPO can facilitate the process for doing that. And then maintain focus on radiative transfer model development and calibration strategies underpinning the microwave SST retrievals. And that's all from me. Thank you. Do you want to do any room for discussion now, or how do you want to do this?
We have, if you want to further discuss or at some point, we have like 5 minutes, so you can, if someone in the room wants to add anything else. It's a micro there.
From what I understand from the discussions, and sorry, I can't exactly remember the name of the sensor, but the SST sensor that is 250 meter resolution seems like it's a question of that or the overlap of AMSA 2 and AMSA 3. There's already a 1 year overlap baked in from what I can gather. So I would have thought GHRSST would be more interested in having the C service. Sorry, it's not. I thought it was. Yeah. Yes, I understand, but
Sure. Yeah, is Kurihara here? Yeah, you can probably talk about exactly what SGLI is collecting. There's the 250 meter radiances that are available going all the way back in the period of record. I'm not sure about how much 250 SST is being produced and kept.
Sorry, I'm sorry, I couldn't get your point. You're talking about the 50 meter, 250 meter resolution. Yeah, sorry. Yeah. Oh. I think I feel working.
So I think that you should
Sorry.
repeat your question to him.
Sorry.
It's better.
So the question is, how long is the collection maintained of 250 meter SST?
How long?
So is that,
Okay. So maybe it's right.
because the full period of record is being kept at 1 kilometer scale, and the 250 is a short time window, is my recollection.
Short time. My question, my question uses just the snapshot data only, no time question. Does that make sense?
The interest is because of the transition to Trishna, SBG, LSTM, et cetera. The SGLI instrument is the closest operational sensor relative to the new spatial scale.
Oh.
And it may well be that those new instruments will end up providing data that's no better than 250 meter, even though their samples are at smaller scale. And it will be really important comparison to the SGLI.
The SGLI started observation from the December 2017. And the observation of 250 meter is limited to the land and the coastal area. But the coastal area is usually from sometimes 600 meter from the coastal area. So the open ocean area is observed only by 1 kilometer resolution, but the coastal area in the 250 meter.
When I downloaded radiances, it looked as though there were data all the way out to Hawaii from Japan at 250 meter in the files. So I'm, yeah, oh, no, this is at the JAXA website.
Actually, all the data is is stored in a G portal system, and you can download not only the Japan area, but also for the global area. But I know that the rule of the data or file naming and file storage system is a little bit complicated. So I will get the information from my colleague with how to get the data in you are interested from the JAXA G portal server. That is okay? Yep, okay. So give me later, give me the email address. Yeah.
So thank you. Something else to add to this session, to this topic, or shall we move to the next one? Yeah. Okay. So next one, I think, is session 2, marine heat. It's your turn, I think, Chris. Yeah. So this is science session 2, marine heat wave. Yeah, so marine heat wave. That's it. Thank you. Or this, I mean, it's normal. But you have more time than us in session 7, which was really last minute. Okay.
First of all, I can thank Andrea Pisano, who was the rapporteur for the session, for making excellent record of the session, which was a long session, as you remember. There's a lot of interest in marine heat waves around the community and generally. Thank you. So to give a brief overview, not of every talk, because it was, as I say, a large session, but try to extract some of the main points that emerged. The overview of the session, we had 6 talks covering the detection monitoring, product development, prediction drivers, and ecosystem relevant applications. And there were a number of operational tools and products introduced. We also talked about other forms of thermal stress monitoring as well. And I think it was very welcome that the discussion at the end of the session will inform the final drafting of this marine heatwave white paper that emerged from the meeting that was held last autumn. One of the things that was very obvious was the sensitivity of marine heatwave metrics to a number of data characteristics. So there's the definition of the baseline and whether there's a treatment of trends or not. But also, I think the data set characteristics, including the data error characteristics, lead to quite different results for trying to do the same marine heatwave analysis on different GRIS data sets. And that means that we do have some work to do to think about how our data sets are representing extremes and variability, as well as the average SSTs that are progressing. So marine heat waves are not only surface temperature events, so that there is interest in the vertical structure, of course, and that means that our SSTs will be interpreted in the context of broader observation and modeling frameworks as well, which is entirely appropriate. So I think these reference matters were not only relevant to MHWs, it was also shown that degree heating weeks are a metric of heat stress that is sensitive to the exact formulation and the exact data choices. And I think that I'll make other comments about how we handle that in the task team context of GRIST a bit later on, in some remarks I'll make later on. So you see that one of the issues is data inhomogeneity, not only biases in data sets over time, but higher order statistics of data can influence the long-term trends and any climate assessments and these sorts of metrics over time as well. So if data become less or more noisy over time, this also has an impact on how these extreme metrics are observed in data sets. In terms of potential activities, which I think very much has to be bottom-up community activities in this case, I think one possibility is to compare GRIS dataset quality with respect to the factors that affect marine heat wave detection. So we talked last year about whether a marine heat wave task team should form. That's still a possibility, but as I say, I think this is very much a bottom-up driven task, not one that it's a GRIS priority to push. But there are certainly lots to do in terms of looking at the sensitivity to these different factors. I think it probably needs to be broader than just marine heat waves, but perhaps there's been more interest if we frame this in terms of heat stress metrics related to ecology and other applications in general. And generalizing that interest might be more successful in generating some collaborative activity. There is the requirement in this area, as in all areas with GRIS, to strengthen the links with the users and the impact communities to understand better their requirements for heat stress metrics, and also so that we can demonstrate how to use our data to meet the particular needs for different applications. Because, for example, aquaculture and coral reef monitoring are not going to need exactly the same sorts of metrics. So we need to understand those requirements. One thing that isn't mature yet is the exploitation of the uncertainty information into heat stress metrics and how certain those metrics are as a result of the uncertainty in the data. And this is something where the technical expertise that GRIST has in understanding the data could make a real contribution. So to me, that's one of the areas that is very appropriate for GRIST to push compared to the larger marine heat wave community at large. And of course, there's an interest in that connection and looking at different ways of dealing with uncertainty. Ensembles is one idea, but there are other data-driven approaches that are possible as well. So as mentioned, there are some GRIS Science Team members that are in the CareHeat team. They have listened to the session and the insights that emerged from that session and will represent what was emerged from the GRIS session in their final revisions. And if we're going to pursue within GRIST the tasks on marine heat waves and heat stress metrics, we will need to identify a clear project and identify a task team, set some doable 1- and 2-year goals to achieve that. And personally, as I said in the previous slide, in my view, this particular idea of how the uncertainties in our data propagate through to these metrics is an area that is more GRIST appropriate than the whole realm of marine heat waves, because I think that does require the sorts of data understanding that we have in this team. But that's my view, and it's really up to science team members who are interested in this topic to generate this task team activity. So that's my comments. Christina, you want to have questions?
I think one of the most useful things GRIST can do is this uncertainty estimation, and because of the complexity from the user point of view of the various algorithms provide you a list of dates when there are individual heat waves and they are particular categories. And so it's a categorical definition that's being used, and it's coming from a continuous variable set of data. And that transition from the uncertainty statistics of continuous variables into the statistics for categorical variables is really important and difficult for the users.
Yes, yes. There was one paper on that last year that I saw looking at how you could express the probability of that category if you understood the uncertainties, but I think there's a lot more to do on that, yes.
Thanks a lot, Chris, for the nice overview. I remember from the discussions at some point, the topic of resolution emerged. So the impact of having data sets available at different resolution, how they can characterize also marine heat waves, and also the issues on generating a higher resolution baseline compared to what we have today, without waiting for many years to collect climatologies from new high resolution missions. So I don't know if you consider it is worth pointing this out in the report. It could be useful.
Yes,
Thanks.
I think that's right. It also arose in connection with the ultra high resolution session as well. But yes, we should reflect that. So thank you for the comment.
Thank you.
Okay.
So it's not clear for me yet if we decided to create this task team or not. I don't know. It's something that it's just coming from a few years. And so as GPO, we will wait until there are some interest in the community or someone who wants to lead this task team. So I would encourage you, if you want to further work on that, send us an email and we will just begin the activities. So for me, it's not clear yet. So, and I will wait until I have news from you. Okay, that's my point. Does anyone wants to add anything else on that topic? Andrea, you were kind of raising your, just approach the micro, please.
Yes, a quick comment. I was discussing before with Chris this morning. Maybe more than a marine heat wave specific task team, we can think to think about something more general as dedicated to extreme events. So including, I mean, from physics to impacts, from atmosphere to the ocean, and so that we can include a broad, a broader range of activities, because the interest, there is the interest. Yeah, that's my comment.
Do you want to lead that group? Are you volunteering? Is that? I can see.
Yeah, we can discuss also, because there is the coral reef task team, so maybe there.
We write in on the report that you are going to somehow try to start this working team. You can name it. I just said marine heat with you because it was a shorter name, but I do agree that as Chris pointed out, it would be better to make it in a general way. I don't want to push you that much.
Today, yeah.
Just a bit.
I suggest that that's a topic of discussion over coffee break rather than in public.
Sure. Okay, so let's move on with the next reporting. Steinar, I think it's your turn. Reporting from the Science Session 3, sea and sea ice, sea surface temperature in coastal and polar regions. Thank you.
Yes, thank you. So this is about session 3. The SST and IST in coastal and polar regions. And I would also like to thank my rapporteur, Vibke Kolbe, for excellent notes. Yes, so the objective of this session was to look at coastal and polar ocean regions, and which represents some of the most challenging environments for accurate SST and IST estimation. And we had 5 very good presentations, summarized here very briefly with these bullet points, with a very large variation in the subjects. The first presentation, the keynote focused on the Calista project, which has demonstrated ultra high resolution SST from Landsat and EcoStress, and showed us all the tough challenges with the ultra high resolution SST retrieval, including the the challenges with the calibration and correction. So, but showed the success of establishing or preparing a service for ultra high resolution SSTs. Then we had the presentation on the documentation of significant bleaching, regional bleaching in this South Atlantic, and also the success of remote sensing data and marine heat wave monitoring, being able to document much more bleaching and than normal methods could. So it was interesting to see also what's happening in the South Atlantic. Then there was the presentation on the comparison of the SLSTR product, which has both a global and regional product, and regional product for high latitudes. And this presentation focused on the comparison of a global and regional product, with which in general showed good agreement, but also revealed some of the challenges when you approach the ice edge, the martial ice zone, and also more challenging regions as Twilight Zone and the edge of the swaths. The fourth presentation was on the marine heat waves, which are also present close to the sea ice, and in this context in the Antarctic, and the challenges with using coarse grid SST products, level 4 products, to study small scale hotspots close to both the coast and the sea ice. And then the last presentations was on the North and Baltic Seas and the CMEMS products for this region, with the adding of new sensors and products and the impact of those, like the SLSTR collection for NOAVIRS, M2G, and preparation for AMSR 3 into those products. So yeah, just to take a highlight or a main challenge here, this talk about the marine heat waves close to the sea ice was something that at least I enjoyed, and then also the challenges of using standard level 4 products for those kind of monitoring. So that's yeah, maybe for something for GHRSST to look at or recommend on. Then identification of priority areas and what should GHRSST prioritize over the 2 next years. That's what was in the reporting template. Well, input to there was a discussion here, and mentioning that the gap analysis of ultra high resolution and coastal high latitude task teams could contribute to. There's several challenges here that or gaps that could be better analyzed. Cloud cover being one, the lack of high resolution passive microwave. I don't remember what that was about. Okay. Lack of nighttime data in polar summer, and several systems using this condition that you only use nighttime data for analysis, and that being a significant issue when you try to do something in the polar summer. So maybe recommendations for level 4 producers, for example, on what to do in the polar summer. We cannot ignore such a long period just because we would like to have nighttime only data. Then on level 4 analysis, yes, there was discussion on whether, about machine learning can replace the classical methods, and whether, yeah, there's both pros and cons on that. And should GHRSST have an opinion or a recommendation on that, or just open every? Yeah, I don't think we concluded on that, but there was a discussion where we should go with that. Then for coastal retrieval methods, they were more technical on the algorithms and how to deal with the coastal versus open water algorithms issues, and where to go with that, and should GHRSST engage in those choices. Yeah, these were the open questions and discussions, and we could maybe try to conclude a bit on that here and now, if that's what we would like for GHRSST to, if you need recommendations for the next 2 years and priorities.
So it's not, the silence is. Do you want to add anything else to this session? No?
We just leave them as questions, open questions for GHRSST. Yeah. Yeah. Next steps, well, we have the ultra high resolution task team being established. We have the high latitude task team well established. So we have people working on several of these tasks, and if you see that some of these tasks or the task team should reprioritize according to the discussions we had at this GHRSST Science Team meeting, I think now would be the time, or yeah, to instruct on that. We will, in the highlighted task team, we will start up the next set of tasks. We have some things that we have concluded on, as we reported, and we are making a new priority this after summer. So if we should prioritize differently, this will be the time to speak up. Otherwise, I don't have more.
Thank you. So anything else to add, or shall we move with the next reporting session? Yeah. Okay. Do you want to add something?
I think I think this ultra high resolution preparation is quite important for GHRSST to be ready for when these sensors do start delivering data. I think it would be useful to get a readout of what the ultra high resolution task team is thinking of doing.
So we have received officially the proposal. I could share if you want to. I just put in the welcome session the objectives, which I think we need to review them because they might be overlapping among other task teams. So yeah, we need to think how to deal with that. Even if you want to, we can do it now. I don't know if you want to review or even later. What? And we have David, which is the co-chair. We have Andrea, which is another co-chair, and Emmanuel, which is, I think she might be sleeping now. And sorry, but I forgot the other one. There were four chair. Cristo, that's it. Cristo, thank you. So. Yeah, shall we do it now? I mean, we are on time. If you want, we can discuss it now. After all the, okay, let's do that. Yeah, after all the reporting, we can just briefly show you what they sent us just, I mean, it was last week. I don't remember the day, but we can go through all the objectives. Okay, let's do that. So let's move to the next science reporting, which is, I think it's Pallavi. Yeah, from the reporting science session 4, climate change, variability, and applications in global regional sea and sea ice surface temperatures. Thank you, Pallavi.
Okay. So good morning, everyone. Is it okay? Good. Yeah. This is overall discussion on science session 4, climate change variability and applications in global and regional sea and sea ice surface temperature. Thanks, Sandra, for reporting. So we need accurate and consistently reprocessed observations in today's fast-changing climate. And this session was focused on the application of these reprocessed CDRs and how SST and CI surface temperature datasets can be used to monitor climate change, analyze trends, variability, and impacts, support applications in models and decision making. So there were 5 oral presentations, 6 posters, and contribution include regional trend analysis over so many areas, Mediterranean, Arctic, Antarctic, near Peru coast, Southern Ocean, Antarctica. So yeah, all over the globe, different regions were analyzed. Long-term observation records up to 40 to 60 years were analyzed and discussed here. Different data set intercomparison and validation, coupling SST with atmospheric processes, climate extremes, and variability studies. So understanding trends and variability, there were several studies in this session that examined regional and global SST trends. They explore how variability is driven by climate modes such as ENSO, Arctic oscillations. Regional variation, so Arctic shows a clear persistent warming signal while the Antarctic has larger interannual variability. So that sort of variations were discussed, and the correlation between marine heat waves and diurnal warming events is not trivial. So more study is required in that sense, and we need more and more these kind of CDRs to make any climate-related decisions. Another important theme was the coupling between SST and the atmosphere. This includes air, sea, heat fluxes, diurnal variability, and interaction that influences weather and climate extremes. So, of course, SST plays a central role in connecting ocean processes with broader climate systems. So in this session, some of the challenges that were discussed was difficulty with processing and storage of upcoming ultra-high resolution satellite missions. So particularly SGLR data at 250 meters, given the huge data set that is gathered, reprocessing and storing is a challenge. Then understanding regional trends. So there was a huge discussion between Arctic versus Antarctic, land surrounded by ocean or ocean surrounded by land. And yeah, very complicated systems. And then also there was a discussion about using consistent terminology. So marine heat wave or marine heat stress in Arctic. So some of the disparities that could address issues are homogenizing methods to connect recent satellite observation with historical SST records. The question for ultra high resolution data in GRIS format, given the volume of these new advanced data. So some of the things maybe need better tune in GDS3 and CF compliance that we are looking after. So the consideration should be given for ultra high resolution upcoming satellite missions. And assess and define a clear near-term strategy for utilizing this ultra high resolution data. It's underused but high value, evaluating mission longevity and budget risk, and building a strong case for serious proposable applications. And then because now we are able to make different CDRs, some uniform information around uncertainty is important for users to choose which one is best for their applications. So overall in the session, long-term SST observations are essential for climate monitoring. The session brought together work on observations, reanalysis, climate applications, linking data to real-world use. Variability and extremes must be understood in a climate context. And session reflects shift from measuring SST, because for some satellite sensors now we have records for more than 40 years. So now we are able to get climate information from these data sets. So shifting from possible measuring SST to understanding and using it for climate decision making. So thank you. That's from me. Any questions?
No further
No.
comments or questions? Suggestions? No? Okay, thank you, Pallavi.
Thank you.
So now we have the coffee break. And yep, and let's make 30 or 40 minutes as you wish. You prefer to do 30 minutes and we start a bit earlier, like 10 minutes earlier than the agenda says? You won't prefer to do that? Yeah, let's do 30 minutes coffee and we restart at 10:20. Yeah. Okay. Okay. Shall we restart? Are we ready? Okay, let's move to the next report from Science Session 5, Advances in SST Calibration, Validation, and Product Assessments and Uncertainty Quantifications. Thank you, Kohei.
Thank you. I will report from Science Session 5. This summary is based largely on the lecture note kindly prepared by Andrew, so I would like to acknowledge his help at the beginning. The 10 talks, covered roughly 4 broad areas: sensor corrections and retrieval, scheme bulk relationship and validation, and L4 product assessment, and uncertainty, and long-term record, and metadata standards. In this report, I will not go through every technical detail. Instead, I will summarize the main point from the talks and cross-cutting issues from Q&A and emerging priorities from the GHRSST discussion. So the first group of talks focus on the sensor correction and SST retrieval. David showed that ultra-high resolution infrared SST retrievals require the carefully correction of the detector level, artifact, and spatial noise. Raj presented a bias characterization for INSAS SST, showing the systematic bias of about minus 0.5 Kelvin with dependencies on viewing the geometry and the geophysical conditions. Ray introduced a high-end 1E COCTS2 near real-time skin SST retrieval with 500-meter resolution and good bias agreement against SLSTR. Key point is that new and high resolution SST retrievals are variable only when the sensor artifact crowd screening, viewing, geometry effect, bias structure, and quality flags are characterized together. And the second group focused on the scheme bulk relationship and validation. Sapporo showed the insert skin SST differed from the buoy bulk SST over the North Indian Ocean by about minus 0.67 Kelvin. But corrections using wind speed, net heat flux, and local time removed the bias. Dr. Wimmer presented the SLSTR validation result for 2018 to 2025 using the radiant metadata from SHIP4SST and match up the database generated with FedEx. The temporal trend was negligible and some degradation in the 2021 to 2022 statistics was attributed to lack of matchup. The key point is that SST validation requires both correct near surface interpretation and robust reference frameworks, including a scheme bulk treatment and also FRM radiometers, matchup databases, confidence level screening, and sufficient matchup. And third group focus on the L4 product assessment, uncertainty, and reliability. Daniel showed that the L4 SST product in the C3S climate data store differ in trend, spectral fall-off, and effective resolution, especially in dynamically active regions. Christopher focused on whether prognostic uncertainty in level 4 product is realistic. Key point was that algo is not fully independent for products such as DOISST and MUR because it is already ingested by those products. Momoe presented a user-oriented framework for reporting the coral temp reliability for coral bleaching applications using great variability observations and anomaly correction map. The key point is that L4 SST assessment should evaluate not only product differences in trend, spectra, and effective resolution, but also whether uncertainty and reliability information are realistic, independent, and meaningful for users. The fourth group focused on the long-term record and metadata standard. Mirko presented the ESA and the sales WGRSS effort to build a coherent 40-plus year IAVHR record with improved geocoding, calibration uncertainty, and error propagation. And ON presented the need for CF compatible uncertainty metadata conventions, including the uncertainty variables, coverage, interval coverage probability, and error correlation descriptions. The key point is that the climate quality SST depend on long-term harmonized record and uncertainty metadata that are traceable, human readable, and machine actionable. And across the Q&A, several common issues emerged. First, independent validation remains difficult. Algo drifters and ships are variable, but some of these observations are already ingested into L4 product. And second, the satellite skin SST, the buoy, bulk SST, and algo profiles do not measure exactly the same part of the upper ocean. So near surface temperature structure matters. The third, wider radiometer coverage would strengthen validation, especially through shipborne and FRM quality observations. And fourth, reliability needs to be application specific. For example, the coral temp should be evaluated in anomaly space because breaching metrics depend on anomalies. And finally, high latitude and ice adjacent SST remains a recurring challenge, especially because uncertainty near sea ice depend on the sampling, masking, and the combination of microwave and infrared information. So the plenary discussion that raised several strategic questions for GHRSST. Should the community prioritize better retrieval, stronger independent validation, or more usable uncertainty information? And how can we expand independent reference measurement, especially shipborne radiometers and FRM quality observations? And how should algo be used given that it is extremely variable in sampled regions, but may not be fully independent for some L4 products? And can ocean car cruises and research vessels contribute more routinely to skin the SST radiometer measurement? So finally, from the GHRSST discussion, several priorities emerged. One is to explore a way to broaden the geographical coverage of radiometer-based validation. And another is to consider reprocessing the experiment with algo, at least as a comparison, because algo is variable but not always fully independent for some L4 product. And we also need better characterization of the near surface temperature structure, including a measurement closer to the surface. And finally, uncertainty and reliability information need to be more usable for both data providers and users, including the decision makers. So the take-home message is that GHRSST is moving from simply products SST field toward the delivering traceable, validated, uncertainty-aware, and user-ready SST information. So that's all I have.
Thank you very much. Comments?
Related to the user-ready SST information, the Copernicus website is great because it has product user guides, it has uncertainty information in documentary format. When you go to PODEC, the only information that's available is a point to the GDS definition. And so I think it's important that somehow these user guides that are being developed by groups like the Copernicus group are distributed to the Data Archive Center that NASA is running. And similarly, if JAXA is producing documents like that, if they are also exporting the documents to NASA, it would be very useful to have that, because right now there aren't real product user guides for the various products developed under Copernicus or uncertainty documentation. So from this user-ready information, I think it's really important that gets distributed to the distribution centers as well, beyond just Copernicus.
Okay, that's a good point. Noted.
I think that's an interesting point from someone looking at it from that point of view, which I fully support. I just comment that that facility on the Copernicus system has come at considerable effort and expense over the years. You know, it's not a thing that is trivially done, and so we have to. Yes, but also they don't exist. The documents don't exist for other data sets. But showing the value of that, and that's very useful that that as a user coming at different services, you've seen the value of that. I think that's a useful comment to show that that effort has been useful and is appreciated by users.
Yes, just to comment also on this, that the main point of information for the GRIST dataset should be the GRIST catalog. And in the GRIST catalog, each dataset is documented by the producers themselves. So they are responsible for putting this kind of additional information, like quality information and so on, so that it's not lost when it's copied to another data centers and so on. This is really the central point, where producers should document all this and where users should find information on a specific GRIST dataset.
Any other comments? No?
Hi, Fan. Hi, Fan. You raise hand, right? You have comment? Yeah, I saw you raise hand. Already? Okay.
Use the micro, please.
Obviously, I like the idea of the reprocessing experiments without Argo, but I'm wondering if there is we have to think about the impact of it, but is it feasible for people to use Argo in their bias correction, but not to ingest the data? Because I think this is the second thing that has by far the biggest impact. Subject for L4 provider discussion, I guess. Would that be do we think that would be an acceptable halfway house, or we don't know yet? Chris, it was your talk that mostly prompted it.
I think that complicates the evaluation and into comparison significantly. If you have some traceability, you really want an independent reference point that is of high quality and, you know, reasonably well distributed, if you are serious about really comparing products, in my opinion. So I wouldn't have them in the chain at all, ideally.
Well, yeah, I get the ideally, but are we interested in explore, because of the distribution, the big impact between things that are assimilated? Take, for example, the Met Office. Ostia assimilates the buoy data, and they validated about 0.2 RMS against the buoy data, but they validated about 0.3 against the Argo. So that's it's a really huge step change, because they assimilate 1,000 points a day or 1,200 points a day from those data sets. And I think it's the fact that they assimilate it that really has the big effect, by far. In fact, I would say if we could quantify it, would you be happy? Like if we said that it had 80 or 90% of the impact was from whether or not you assimilate it directly. Because I can see
you can't if you can't make that assessment if you've complicated it by having some influence within the chain. It's no longer independent then.
Well, obviously it's no longer fully independent, but
so you just can't make the assessment unless
but
you trace the influence all the way through, which is very complicated.
Right.
And John's nodding, so I know I'm right.
But you could perform an experiment to see what the impact was. I'm just saying because of the distribution of Argo in particular, it's quite unique in its ability to sample the entire globe at sort of coarsest resolution. So you would essentially potentially disrupt the bias correction fields for something like the daily OI quite a bit if you did not include it. But I'm not sure if you would necessarily affect the, I think we could do an experiment maybe with the daily OI where we basically allowed it to be in the bias correction, but didn't assimilate it and see what the difference is. And I suspect it's going to be very marginal, 100th of a Kelvin probably RMS difference. Just saying. You have no objection to the experiment being performed?
You want to do it,
right.
You can do it, Andy. Yeah.
Okay.
Whether it will tell you what you think, I am not so convinced.
Now I do. Yeah, but it's not Argo related. But I was thinking, there's an update from Bureau of Meteorology is that we are trying to get a second ISA up and running on a new research vessel, New Ina, from Australian and Arctic Division. However, experience from investigator has been challenging sometimes. And also the lady, Nicole Morgan, some people from this room know her. She doesn't have much time to process ISA data from the investigator, and let alone the new ISA from New Ina, which I think is going to be very useful in the Southern Ocean to get more ISA data. Another question is, sometimes Southern Ocean is so cloudy, and from the whole voyage, like a few weeks, and Nicole said once there was a voyage, and we only obtained 45 minutes of cloud-free data for example, satellite Kelvin. And I was wondering what this room thinks of that. So it's a lot of work. You put the instrument up there, but you don't get a lot of useful data in the Southern Ocean. I mean, it's useful in another way that you can look at the skin SST and you can look at depth SST. You can do other scientific studies other than validation. But how can we better justify that? I want to hear comments from this room.
Just clarification. Your question is to validate the SST or to identify the ice?
Validation of satellite SST. So, I mean, I guess my question is, if people are pushing back, you want to put this ISA up and running, but that requires human resources and things like that. But it's not going to give you a lot of good data for satellite validation because it's just too cloudy in the Southern Ocean. What should we say to convince them it's going to be useful? We're going to need that. Do you have in other areas, do you have similar problems? Or is it?
Yeah, cool.
There's actually two very good reasons. One is microwave sea surface temperature, but the other one is level 4. We do precious little checking on level 4 underneath clouds. We just assume we get that right, and I'm pretty certain we mostly get it wrong. So they're both very important uses. So I would tweak the way that you say usefulness. It's very useful for validation of sea surface temperature, just not direct measurements of thermal infrared temperatures.
Yep.
I was going to point the same. So here is microwave that plays an important role.
Yeah.
At the end.
Yeah.
Yeah.
That's a good point. I should have said that to them. Yeah. Anything else? Like we use LISA to study the cool skin, for example. Any other applications that we might use LISA?
I have a question about the microwave things. The microwave and radiometer is looking at different depths. And many years, people talking about bulk skin, that problem, subskin problem, right? So even that problem we have, that microwave still useful for the radiometers. And one thing I want to say is, if you want to calibrate or validate or developing the algorithm, just picking the data where wind is blowing, the homogeneous layer there, just only picking that no stratification area is maybe better for the developing the algorithm, I think. But what do you guys think?
I think it is. I think it is the case that you can do a lot by selecting your cases appropriately, yes, and then using subsurface measurements of other sorts as well. But we do have under certain wind regimes, we have pretty good understanding of the skin effect, relatively good models of the skin effect. So that's not an impediment to using radiometer microwave comparisons, I think. Again, so long as we perhaps don't go to the very high wind extremes, where I think probably those skin effect models are not so valid.
I see. Please.
Yeah, I was just thinking that collecting skin temperature measurements and improving skin effect models does, and particularly under, different flux conditions, which you definitely will have under clouds, is actually potentially more useful to enable you to do that bulk to skin conversion from the in situ, drifters and stuff up to the skin. So, and it helps you to maybe even do, improve parameterization to subskin as well. So collecting these measurements and the metrology is useful. If you just want it for validation purposes of infrared, because let's face it, skin temperatures are for infrared much more than they are for microwave, then the ideal would be to have a fleet of radiometers, and you just you take a look at the cloudy likelihood of cloud, and you'd put them on ship tracks that were going into the cloud-free regions. Then you'd maximize the return on it. I remember Peter Minette talking about a cruise he went in the Arctic, and he said we had 67 overpasses. And there were 67 cloudy overpasses. So we got no useful information out of that at all, but at least for validation purposes, but they collected a lot of useful skin effect information.
Can I just add on the slide here? I appreciate the final sentence there and the way in which it's framing. I think this transition has been happening for a number of years, but it's a nice summary of the changes that are happening. So I appreciated that.
Okay, thank you once more. So we move to the next session, Science 6, Owen, on the satellite-based SST for operational numerical weather prediction, ocean modeling, reanalysis, and climate models. Thank you, Owen.
Okay, this is the report for session 6, the priorities of SST for NWP, ocean modeling, reanalysis, and climate models. So overview, we had one keynote presentation from Sean Oshie on LETKF-based ocean research analysis, which was talking about using an ensemble Kalman filter for simulating Himawari, SMOS, and SWOT into an ocean model. There was also a discussion of the optimizing the frequency of data assimilation to avoid the model shock. In addition, we also had 5 posters on new updates to SST datasets and assimilating SST into analyses. For the discussion, we had 2 key issues raised for future priorities. First was how should we advertise GRIS datasets to end users? So there's the issue with a lot of users are already just taking error 5 and more or less assuming it to be an observational data set. And in the future, error 6 is going to be using HAD ISST and SST CCI as a daily constraint for the ocean model, and then using the atmospheric forcing to add a diurnal cycle on top. So the resulting data set is going to be very nice for end users because it's a global hourly SST with a diurnal cycle, but it's not an observational data set necessarily at this point. So we've got a risk that more people are going to rely on the reanalyses products and assume that they represent observed SSTs. The other issue that was discussed is how can we help users understand SST uncertainties and make sure that they get used in climate models, etc. So there's already 2 ways we're addressing this. There's the proposal to add standards for uncertainty to CF conventions, which will ensure that anyone producing an observational data set or working in climate modeling can follow the same standards to encode uncertainties. You can write tools that can read them and propagate them to different resolutions or propagate them into your model and so on. And we're planning to adopt these conventions into GDS3 when they're ready. There's also a CCI project, ESO for Klima, which is working on ways to improve model to observation into comparisons using things such as sampling the model data to the same locations as the satellite observations, and also it'll be looking at how uncertainty should be used within the climate model evaluation. So that's the summary. Are there any questions or further discussions? Andy.
Do we know what the parameterization is for the diurnal warming model? Have they said?
An error 6.
Yeah.
I do not know the details.
Okay.
Anyone else?
Okay, maybe. Thank you, Owen. Okay, and last but not least, reporting from Science Session, Advances in Computing, Artificial Intelligence and Cloud Computing for SST Observations and Products. Let me give her the credit because she was a fantastic chair and a reporter as well. So she did both. So thank you very much, Claudia, for all your help.
Thank you. And I want also to thank my rapporteur, Christina, for helping me in this. So yeah, I will first recap which were the main topic of these sessions. So the session was about challenges and advances in various computing techniques, artificial intelligence and machine learning applications, and challenges and advances of cloud computing and storage technologies. I will give a more general overview rather than a specific talk-by-talk explanation. So limitations of current SST products and forecasting systems have been assessed. This includes weak representation of extreme events, regime transition, long-range dependencies, prediction uncertainty, and physical consistencies. So it was clear that AI is becoming central to SST product generation. It was a wide variety of type of methods, from physics-guided climate foundation models to 4D VARNet reconstruction, UNet gap filling, and machine learning-based cloud masking. So the session showed that AI being used is being used not only for prediction, but also for other applications such as quality control, reconstruction, uncertainty-aware products, and regional services. Cloud contamination remains one of the most prominent upstream challenges. The cloud masking presentation of Aina highlighted biases caused by residual clouds, especially near cloud edges, while other presentations depend on reliable cloud filtering for producing accurate SST analysis and L4 products. So physical consistency and interpretability were recurring concerns. It was highlighted from everyone that AI-based SST products must preserve ocean dynamics, physical plausibility, and climate relevant variability, rather than acting as purely black box statistical tools, which we understand is a big concern. Cloud computing and data access are enabling conditions for modern SST science. At presentations showed that virtual dataset, ZAR-style access, S3, HTTPS workflows and tools such as Virtualizer and IceChunk can reduce data movement and accelerate analysis from hours to minutes, which was impressive. It has been highlighted that there are three major pillars for cloud optimized sciences, which are data virtualization, optimized data access, and optimized compute. And as Ed said, it's all aimed at faster and more repeatable workflows, which is very important for us. Another issue was the operational readiness. So several contributions move beyond proof of concept methods toward deployable workflows. So as I was saying, cloud-based VDS operation and AI reconstruction methods designed to run on a practical hardware. But validation and trust remain essential. So all the presentations stress the need for independent validation with in-situ data, dynamical metrics, uncertainty awareness, which was a big topic, and comparison with existing global products to build confidence in AI-enhanced SST dataset, which I think is something that maybe there is a lack of it. So overall, the session highlighted a transition from traditional SST processing toward AI-enabled, cloud-ready, physical-informed, and operationally scalable GRIS product with cloud masking, gap filling, uncertainty, and coastal high resolution application as the main challenges and opportunities. We identified some priority areas with not a specific order, let's say. So it was clear that it's very important to have efficient cloud access. An important topic was to take into account physically constrained AI. It was also important to have scalable global inference. One of the bigger topic, as I was saying, is the uncertainty-aware reconstruction and forecasting. It has been highlighted that we need to better handling the extremes and multi-scale variability when using AI approaches. And finally, it was let's say, it was said that it's quite important to have community-friendly workflows. So the steps that have been identified, it was firstly strengthen the capacity building for SST data, both producers and users, to support the effective adoption of cloud-optimized data formats, access methods, and processing workflows. There is the need to organize training activities on cloud-based SST data exploitation, building on existing material and targeted audiences with different levels of technical expertise, from beginners to advanced users. So Ed has volunteered to lead a dedicated webinar focused on cloud computing training in the next month, I don't know. There is the need to advance methodological work on uncertainty quantification for machine learning basis SST reconstruction and prediction. As I said, this was the major concerns in this community. And finally, maybe we need to establish validation and intercomparison protocols for AI-enhanced SST products, ensuring that the uncertainties estimates are evaluated against independent observation and are suitable for downstream climate and operational applications. That's all. Thank you very much.
Okay, thank you. Further comments?
I think it's you, Chris.
That's a very helpful set of next steps and implementation. Thank you for the summary. On the training activity, which I think is great, I wonder if we're having a user symposium next year, whether that's also an opportunity to maybe repeat or expand with people in the room, that sort of training. Perhaps users who are coming to the symposium would benefit from actually being able to talk to you and interact with you on their laptops and so on, and pick up some of these techniques in person.
Yeah, that's an excellent suggestion, Chris. And it might be even helpful if, like, before this would be conducted, that users would come to me with a problem statement, right? That then we could work through, and I have a prepared workflow of how to do the problem and the scientific analysis and stuff. So not, something straightforward that we could accomplish like within 15 minutes, and it's part of the training session. Something like that would be good. I mean, I have my own ideas of like scientific analysis and the products I use and stuff like that, but other folks might be having something else, dynamic climatology building and stuff like that.
Maybe like we can set up a form to when you subscribe to the workflow to say which are the main topic or the main issues that
you would be interested in. Yeah.
Whereas like I demonstrated in my talk, I just took somebody's paper, right, and just reproduced the results. I could do something like that too.
Yeah, definitely. We can think about it. That's a good idea.
Ed, you might benefit from partnering up with like the Copernicus training people Like CoastWatch is a smaller version of that, but with the people who do the training all the time, like you've got that technical expertise in the topic, but the trainer people know, they do things ahead of time, they put out information, they gather questions ahead of time, they've got all that going on already. So, it might be less organizational work, and then it might bring in even more people if you're interested in having like a more, some of these meetings do a training session a day ahead of time. NASA does that a lot of times. So anyway, it was just an
Yeah,
idea.
I've lost track about who those Copernicus people are, so if somebody could put me into contact with them.
Yeah, I can tell you who they are.
and even at EMWESAT, they have people dedicated to training, so we can further
As you had
discuss.
said.
Yeah.
Yeah.
Yeah, Joanna.
Maybe more than Copernicus, maybe the EUMETSAT training team would be relevant, Ben and Haley.
Yeah,
and they've already.
That's what I said.
The EUMETSAT. Okay, sorry.
That was my point. Yeah. Yeah. Okay. There's a comment online.
There is a comment online.
Yeah. I'm not sure if it's Helen because it says Zoom user, but I think it used to be Helen. Helen, do you want something to? No, it seems we are fine. Okay.
Jeff.
Yeah, I was just wondering if there were any requirement from AI applications on the way that we format and distribute the data, because often for such application you have like a transformation step for your data. So are our data really AI ready? Are they easy to use for this AI application? Should we do something about the way that we reformat the data or distribute them to make them more usable for AI application? It would be nice if in the next meeting or if the people presenting things on AI also emphasize the requirements they may have to improve the usability of increased data for the application.
Yeah, and correct me if I'm wrong. So for me, one thing it's AI that you run it on your, I don't know, high performance computing server, or another thing on the formats might be the need to accommodate the formats for cloud computing. I don't know, did you know what I mean? So for me, there are two different problems. I don't know, I think, what is your opinion for as a user?
Yeah, I'm not sure. Yeah, I think there are two different topic, no? Not sure about this, but we can maybe talk about this a little bit and get into.
Yeah. So what I mean is that if you are using some AI algorithms with the NetCDF format, must be fine. I mean, there are a lot of libraries in Python running and dealing with that. Another thing is the format that you use for cloud computing. And that's what Ed's presentation yesterday, I think. No? The chunks and all the considerations you need to take into account, or chart, the chart format, or yeah.
Yes, but between this and the usage in your AI model, there are some steps involved to make the transition to feed the model and so on. So I was wondering if the way that we deliver the data now is not good enough to ease this step.
Okay, noted. So
It's
how
a
do you want to
question,
deal? I mean, it's just to have the user's feedback. What do you mean?
Yeah.
Okay. Any further comments on that? Okay. With that, we ended the science reporting. Thank you, Clyda, again. So now I think we have a slot for the news chair's reflection on GRIST priorities. So Chris, it's your turn.
I don't have any slides, but you kill that one. Yeah. Well, it's been my first GRIST meeting as the new science team chair. I've very much enjoyed it. I appreciate very much everyone's contributions. I'd like to start, of course, by thanking our hosts for such a smooth running meeting. It is not trivial to make a meeting run as well as this has, and that's really appreciated. I've appreciated the variety of contributions from everyone very much. GRIST is a group that brings together operational concerns, academic and scientific concerns, and sort of engineering and technical concerns. That's relatively unusual. I think it's one of our strengths. It's also requires patience as we discuss things like formats and which interest some people, but not other people, and then the details of some scientific processes, which interest another subgroup. But sharing all that together is really important for us. And I think that that is one of the reasons that this community has been successful over the years is bringing these communities together and having that patience with all those different concerns to make something greater than we could do in our different types of focus. So we are trying to do something that's very difficult, which is to put remote sensing and observational science into products that have a wide range of users, from forecasters to even commercial services. And that's not just a computational and scientific challenge, it's also a sociological challenge. You know, it's a lot to do with communication, a lot to do with understanding the needs of different communities. So thanks for engaging in that. And it pushes us beyond our normal focuses, I think, but it's a very useful thing for us all to be doing together. So in this meeting, I think we've seen that we have some interesting challenges coming up, particularly in the field of engaging with data at less than 100 meters resolution. This is going to be the frontier for us, I think, in coming years. And of course, that's very relevant to the coastal seas in particular. And that should be something that makes our work even more relevant to ecological applications and also various forms of human amenity, because there's a lot of use of the coast that takes place, and our data will be part of the resilience of that usage as we face the future in the changing climate. So I'm keen that we try to broaden our collaboration on that particular area. The coastal SST activities, I think, are going to be important, but also we have opportunities to revive our work on inland waters, which was at one point a bit of a GRIST focus, and I think with the increase in resolution, that will be something that we can also contribute to significantly in future as well. I just mentioned again the opportunity we do have with SGLI, that I think is true. We have underused as something of a bridge towards that new scale, and we will be following up, well, following the request to think about our priorities in terms of SGLI and also the exciting new arrival of the AMSR3 dataset. So we've noted that, Masako, and we'll follow that request. Now, we've had some discussion of marine heat waves, a lot of discussion about marine heat waves during the course of this meeting, and also other forms of thermal stress. In some discussions, I think we've reached something of a consensus that we need to be reframing that as a GRIST priority to look at how extremes are represented in our data, extremes of heat and the stresses that that causes on ecological systems in particular. So I won't say more about that just now. I think Christina is going to talk about the task teams for the coming year in a moment. But I think a slight reordering of how we think about marine heat waves and the other heat stress task teams is going to be helpful in encouraging us to collaborate on that topic. Now, we had a workshop about GDS3. You've got to mention that because, as I said on day one, this is only version 3 and we're at GHRSST27. So this is a momentous meeting in that we're moving forward to GDS3 in the coming year. And although that perhaps wasn't everyone's most exciting session, although some found it more exciting than others, of course, I think it's incredibly important. If you're relatively new to GHRSST, you may not be aware of how much influence that sort of effort has had over the years. We were one of the first communities to get organized in terms of data sharing in that way. And that then influenced the whole structure of the CCI program and the Copernicus program and many other programs around the world, I'm sure. I'm just talking about the ones I'm familiar with. And by making this change to GDS3 in conjunction with the CF convention, I think we'll be making our data more accessible to an important user community, and that's the climate modeling community, as well as other users as well, who will become used to these conventions and increasingly use our data over time, I think. So that's an important step forward, and thanks to all the people working on that who will progress that in the coming year. Now, I think in some ways this meeting has been positive compared to last year's meeting for some of our colleagues, especially the situation in the US has stabilized, and we're happy about that. And that means that we can start thinking more about the science and our collaborations together. There are resource pressures everywhere. That makes coordination, collaboration, working together, sharing ideas and sharing resources, of course, ever more important. And that's what this group is for. Most of the work, of course, gets done in the years in between the meetings. And we appreciate that we're not always funded to do everything that we think is necessary within GHRSST. That we try to align the priorities we set ourselves with work that people have to do as part of their day jobs, but very often we're relying on people also going that little bit further to do something that helps GHRSST advance its priorities. So thank you for doing that in the coming year in your various task teams and various projects. That sort of collaboration is ever more important when we are facing times of resource restrictions and pressure on budgets. So I'm looking forward to working with the task team chairs, perhaps a bit more actively in the coming year, to try to encourage those task team activities. I think the key with a task team is to have a very clear focus at any given time about what we're trying to achieve, and hopefully focus that excites people because it's an interesting scientific problem that will lead to an impactful paper and some advances in that sense as well. I'll return to this sentence that was presented in one of the priority reports, that we shouldn't think of ourselves as producing data, but as producing traceable, validated, uncertainty quantified, and user-ready SST information. That's a nice summary of where we're at, I think. And information isn't just data. Information goes beyond data. It's data in a context. And as well as communicating how we interact with our data, it's also our job to put our data in contexts that communicate. So climatologies and background information about how our data are made, things like color scales, all those aspects are part of putting our data in a context. And that is our responsibility as well as the science and the data as well. So I think that's a useful way to look at it, and I encourage you to think about your task team activities in the coming year from that perspective. So hopefully those are a few useful comments to frame some of the things we've discussed in the meeting. And lastly, just thank you very much for being a great team, and I look forward to serving you in this role in the coming year.
Okay, let's go. So we'll try to complement what Chris have already anticipated. And indeed, it's going to be funny. You will see. We didn't talk about that. I didn't know how he was starting, but we are going to do it in a similar way. So yeah, this is my first meeting as well as GPO, and let me thank Ewald, who didn't know this community before, and I think he did a really fantastic job in managing and preparing for this meeting. So thank you, Ewald. Yeah. And for sure, thank you for all the local organizers, Hokkaido University and JAXA, and all the volunteers that we have seen around here. So thank you very much. Thank you very much for that. So that's what I wanted to, yeah. Okay. And continue on what Chris was saying, I'm pretty sure, and I think we all agree that the success of this community is built on that collaboration, in all this kind of collaboration that Chris stressed between agencies, users, and engineers. So this is a great opportunity, and I think it was really, really nice to have had the chance and the opportunity of seeing all these and all the achievements that the GRIS community have performed during the last 42 years, which is kind of amazing by the hands of Jorge Vázquez. And yeah, so thank you very much for that. And now we are going to wrap up on the the work. Let's back to that. These are the main objectives that the new task team, the coastal task team on ultra high resolution have set. So as we agreed before, I just included here the main objective that they came. So if you want to, we can go just review each one. So it's identify and document scientific and operational user requirements, which I think it's a common objective for all the community, indeed. Compile and maintain information on existing and future ultra-high thermal infrared missions. So I don't know, maybe I was thinking now, and maybe it's just David or Andrea, do you want to present this, or it's me that I'm giving you the opportunity. I just thought about it now. So if you want, yeah, do you want to? No? Okay, I go. So I keep going myself. But just if you want to add anything else, just jump in. So the other objective is provide harmonized approaches for SST retrieval algorithm and uncertainty estimation, where I think it's another common objective for all the GRIS community. Facilitate access to in situ validation datasets and fiducial reference measurements. Assess and improve cloud, water, land, and ice masking methodologies. Investigate sensor noise, stripping, and geolocalization and reprojection issues. I think among all we have said, I think this, for me at least, I don't know this is my personal view, but I think this is going to be specifically critical for this ultra high resolution. So I might suggest to put this as a first priority. Maybe, I don't know. Let's recommend ancillary data sets and atmospheric correction approaches, contribute to extending the GRIS data specification standards for ultra-high resolution products, promote interoperable tools for visualizations, collocation, extraction, and analysis, and encourage collaborative publications, intercomparison exercise, and is everything well there? Okay. And demonstration projects. So these are the main objectives, and then we have a document that we can share with all the community if you want to, with more detailed objectives. But yeah, so I will just suggest all the science team members to contact the chairs, the 4 chairs that we have here, Emmanuel, David, Andrea, and Cristo, and please copy always the GPO so that we are aware. So this is a calling for task team members, okay? Do you want to further comment on that? Anyone in the room? Yeah.
Well, this is obviously a very big laundry list of many things, and we're going to probably reduce this to 2 or 3 at the most, because you can't get more than that done in a year.
Any further comments on that? Okay, so we hope and we will wait for your interest on joining this. I already expressed mine, so come in. So the next task team is going to be the passive microwave task team or working group, as Misako prefers to call it. So the potential chair is Misako Kachi. And so this is another call, potential collaborators, otherwise Misako will contact you, I think, maybe. So please, to get involved, just contact Misako and ourselves at GPO, okay? And last but not least, we came with a general name that we think it frames all the what we have been discussing and that Chris was summarizing before. So it will be the new task team, heat stress, that will chair Andrea. Well, I said potentials, but it's confirmed. I think Andrea and William agreed to do that. So this is another call to all of you. If you want to join this task team, please contact Andrea and Cristo and ourselves at GPO, okay? Do you want anything? Do you want to add anything here? The potential chairs? I just leave you, no, it's fine. Okay, so let's move on. I think, do you want to, you can keep on.
Yeah. Okay, so thank you everyone for your warm welcome to the English community. First of all, I wanted to thank you that by myself, and yeah, looking forward to working with you in the following years. So yes, as Christina was saying, I think I already told several of you, we plan to come back with the GRIS talks, so these webinars, starting from September, October. So we are aiming for that. And here in these webinars, so they are relaxed meetings that serve as an opportunity so that you share your ideas and discuss methods, the methodology, and communicate results regarding SST. So we invite everyone that wants to be part of this to present their work, especially early careers researchers and poster participants, so that they can give more insights on the work that they have done. So if you want to be part of that, yeah, just send us an email to the GPC email, and we will plan to have you doing the things. Also for the testing reporting, if you want to share your advances prior to the science team meeting, you can not wait until then and communicate that with you, and we will present your advances. And then regarding the science team members updates. So well, here there you have for regarding the renewals. So well, as you know, we sent the email on Thursday, yesterday in the morning, and thank you all for your involvement on that, because we have received a lot of involvement in this. So well, as we all know, Jorge Vázquez has retired, so he will not be serving as part any longer as part of the science team. Yeah, he will be present in everything, and he will be providing his knowledge on everything. But yeah, I mean, he will be here for several years. Then regarding Marisol Garcia Reyes, she did not stand for renewal because of the project she was working on. The MIS project has ended, and she thought that it would be better for her to not stand for renewal. And then regarding the remaining members that were due to renewal, they were all renewed following the email ballot. And then I'm glad to also to welcome to the new members elected. So we have two here representing in the room. So we have William Skirvin from the University of Reading, which has been nominated by Chris and Jonathan and Mithat. So we welcome you to the science team. Then also Kohemi Zabata, I think he's also there from University of Tokyo, which was supported by Misako and Yukio Kurihara and Mike Chin. So we welcome you as well to the science team. And then from home, Hishad, he's a colleague of NERAG, which he actually nominated, and the nomination is supported by Prasan Hitash and Pallavi here in the room. He's from ISRO in India. Yeah, so let's welcome them. Okay, so regarding the new, the incoming year's GRIST in meetings, so next year we will have, it will happen. We already have the dates even, so from the 21 to the 25th of June next year in Brest, France, hosted by Ifremer. Here we have Jeff representing that. So yeah, well, we will go to Brest and the science team meeting. You want to add something?
I'd be happy to come back home with many, since I did my postdoc there, so it would be nice. Thank you.
And regarding following years, for 2 years from now, we have here Kenyo Park from the University of South Korea in Seoul. So we will, which will host this science team meeting. The dates are to be discussed, to be defined yet, but we will inform you in once we have everything ready. So yeah, thank you for you hosting the meeting. Do you want to add something? If you want. Yeah. Okay. Do you want to talk? Okay.
Thank you.
Yeah, for the people at home. So.
Yeah. Thank you for choosing Korea for GRIS meeting 29th. We will try to our best for successful meeting. So actually, we have prepared for some Seoul National University souvenir even before official decision. We have 14 souvenirs. Please take one. Thank you. Thank you so much. Yeah.
Thank you. Thank you. And now also from my side, because and also from Christina from the GPO, thank you to the local organizers because indeed they have been very helpful, and well, we all have seen all the support and all the work that they have done. So thank you.
I will ask you to come here, please.
Wow.
All the three of you. Thank you. The three of us, please. And we consider you are a representation, as I said, of all the other teams. So just translate our big thanks to them. And we just wanted to give you a small present from, we just brought from Spain. You know that GPO now it's based in Spain. So it's just a small detail from Spain to really thank you all your work and the really nice job you did for hosting us here this week. So thank you very much.
You come here so that also people at home, perhaps, yeah, so that they can also see. No, so yeah, we. Yeah. So well, this is a present from Spain. So this is a very typical thing you will see, so that you feel also the essence and the taste of Spain. So hopefully you will enjoy it. Thank you. Thank you.
So I'm very excited to be going to Brest next year. Thank you, Jean-François. And then I have to say that the visit to Seoul is already in a good state of preparation. And as Kyung-Ae mentioned, she has brought some souvenirs which are available to 14 people. Only take the souvenir if you have hold baggage, because you will not be able to take it through in hand baggage. So maybe that will reduce the competition a little bit. But Kyung-Ae, I think, has put the souvenirs she's brought on the table outside, and she doesn't want to have to carry them back. So that's very kind and very, very far in advance prepared.
Thank you. So just to end up, now we have the reporting of the Advisory Council from Pallavi, and I think that with this we might end our science meeting this year. Thanks, Pallavi.
So, hello. I'm happy to represent Advisory Council here as a chair. And I would start with thanking JAXA and Hokkaido University for arranging this meeting and running it so smoothly. I would also like to thank GPOs for all your support, and Chris Merchant for running this meeting so smoothly. So Advisory Council met a couple of times before and during this meeting, and we have some recommendation for the science team. So as you would like, encourage science team members to be more active, inform all of your GRIS-related activities and publications to GPO so that they can make it visible on the GRIS website. Also, with support from the GPO, enhance the visibility of GRIS activities and data sets that you are creating, including promoting them through open access channels. We are moving to the AC and cloud world, so users need training. So whatever the training material you have, please consider contributing with GPU. Support efforts to expand and populate the GRIS data catalog. So if you are making any new product, please add them to the GRIS data catalog. Help elevating GRIS profile in big conferences that you are going, like AGU, to engage early career researchers in GRIS activities and promote activity through your existing network. We recommend to identify and support the increase of participation of early stage researchers in GRIS to help build capacity in the new generation of SST users. Also, in your network, encourage mid-career researchers to take more responsibilities so that we build up next capacity in the GRIS. Consider alternating agency reporting and international SST user symposium. So I think from next year that is going to be in place. GDS3 and CF conventions, those things are important going forward. So continue contributing to the evaluation of those things. And Christina just listed new task teams that are coming, including microwave, coastal ultra high resolution, and then the heat stress. So please consider joining and contributing those task teams. So thank you, everyone. That's from AC.
Thank you, Pallavi. Maybe we forgot to announce that you will be ongoing chair next year from now on. Can you announce the new incoming?
Yes, sir. So yeah, first thanks to Marisol for the who was outgoing chair this year. So thanks for her last 2 years hard work towards the AC. I will be outgoing chair this year. So then Sujan Wang from Chinese Meteorological Agency will be incoming chair. So thanks Sujan for accepting it. She will be incoming next year. Yeah.
Thank you. And I think with that, we just end up, we managed to get at the end of the week. So thank you everyone for your contributions, your collaborations. I don't know if the local host would like to say something as a final remark. I just open the floor to them. And from our side, just wish you a pleasant stay in Sapporo, Japan, if you manage to stay here. And hopefully see you all in Brest next year. So Misako, if you want to say something, or Professor Ibuchi, I will kindly ask you to just end up and wrap up the meeting. Thank you very much.
Thank you very much. Thank you all for joining and come to Sapporo and join the GRIST meeting. This meeting is fully supported by the Hokkaido University and the staff and the students. It's helped us to organize the online setting and also the break, the coffee break preparation for everything. And also there is a support from the JAXA staff who cannot come here, but they will support the someone's visa, the application and any other things. And so I think that and also the Eri, she is working very hard for the preparation and communicate with the GPO. So and of course the Ebuchi sensei, and he is working also very hard for this setting. So we also have the several the people, Mizobata-san and the Kobashi-san and the Tobicha-san. Those are also the working for the local organizing committee and making the proposal for the session from the Japan. So I'm really happy that the meeting is very successful, and of course we are facing tomorrow's typhoon in Tokyo area. So please be careful and checking the weather forecast and also the announcement from the airline. The Sapporo area is not affected, I think, but when you use the Tokyo or any other city in Honshu Island, you may be really aware of the status. So that's all, and please safe back to your home country. Thank you very much.